Greetings, this is Artie from Artifact Electronics. In today's episode we'll be looking at this Roland D-5 synthesizer. I have had this for a while and it is in non-functional condition. When I bought this, the seller told me that somebody had most likely plugged in the wrong power supply, and after that the instrument stopped working. So let's have a look at this and see if what got damaged when the wrong power supply was used. Talk a little bit about what sort of power supply was most likely used to damage it, and have a look and see if we can get this to work again. The instrument is generally in nice shape. I did have it in storage for a few years, so it was pretty dirty. I mean, it was pretty dirty to start out with when I bought it, and sitting there for a few years didn't help things, but after giving it a good cleaning, it looked okay. But I did find something that I had not seen previously, and you will notice these fingerprints on the keyboard. And these are not just simple surface marks, but rather these are etched into the plastic of the keyboard. We can also see signs on it on the volume control and other plastic parts that have been affected by whatever solvent was on the fingers of the person who played with this. Now, I repeatedly tried to clean these, but these etchings won't come off. I did clean it very well so as not to have any residue of whatever this was stay on it, but it looks like this. It doesn't affect functionality. It's a bit annoying when playing the keyboard and hitting the rough spots, but I guess it's a good way to learn how to play by touch, because certain keys are marked and you can tell what key you're playing without looking at it. But depending on if this can get fixed and if it sounds good, I may be on the lookout for a donor keyboard, because an entire keyboard will probably be cheaper to get rather than replacing the 10 or 12 keys. And actually it's more than 10 or 12 keys, because you can't really see it on the black keys, but several of the black keys are also affected, and such as the one in the middle. So it's probably not a bad thing if I could find a donor keyboard for this. But first, let's go ahead with the electrical repair and see what we can find. It is actually quite common for people to damage their instruments with the wrong power supply, because power supplies come in all shapes and sizes, but the kind of power supply, or the kind of plug that these era instruments used, Rolands, Korgs, and many others, are this connector called a barrel connector. And if we look at this and measure the diameter of it, and let's make sure that that shows up. It says 5.68. These things are not very accurate. This is commonly the proper measurement is it's a 5.5 millimeter outer diameter plug and a 2.5 millimeter inner diameter plug. The point is that the plugs that output different voltages and different polarities all have the same exact plug, which physically fits the instrument. So some people don't even make an effort to check the specs of the plug and just plug it in. Other people will look at the voltage, and if the voltage matches, will use it. But what is the most important part is to make sure that the polarity matches. And what the polarity is, and you can see the little drawing on here, it shows you whether the positive part is on the outside of the plug or on the center part of the plug. And on this particular one, the outside of the plug is positive and the center of the plug is negative. And that's exactly what the instrument requires. Now, if you get a plug that says 9 volts on it and you don't pay attention to the polarity, and the polarity is reversed, i.e. the outer edge is negative and the center is positive, there's a high likelihood that you can damage the instrument. Now again, the instrument itself will have a diagram similar to this on the back that not only tells you the voltage but also tells you the polarity. And unfortunately in this case the 9 volts is really large, as if it's the most important thing, and the polarity is small, but the polarity is actually more important to be matched. Because if the voltage is slightly higher, it really won't damage anything, and if it is too low, the instrument just won't work without any damage. So here's looking at the back panel, and we can see the power connector right here, and that it should be abundantly clear what it is asking for. DC at 9 volts. It will consume up to 800 milliamps, which means your adapter should be able to handle at least 800 milliamps, but it can be higher than that. It won't hurt anything. It can't be less than that. Then we see the polarity indicator telling us that the center is negative. So it's a center negative supply that it needs. And underneath, of course, it says you use Roland AC adapter only. That's a bit of a lie, because you can essentially use any adapter that matches these settings exactly and that have the correct connector that fits into here properly. I went ahead and downloaded a copy of the service manual, which is nice and legible. While you're at it, you may also want to get the user manual, because I do recall that this particular, the D series, well, maybe not all the whole D series, but the lower D series, the 5, 10, and 20, had a bit of a non-conventional user interface, and the manual really does help out. I've also seen people ask me to fix these for them, where they thought there was a hardware failure, and all that had really happened was that the patches had gotten corrupted and weren't outputting any sound. And before taking an instrument like this to get it repaired, if you have the manual, you can actually test it with an initialized patch to make sure that the patch is not preventing sound from being generated. Looking at the input circuitry, pretty conventional, nothing out of the ordinary here. Power connects here. This represents the center of the plug, and this the outer sleeve of the plug. And we can verify that it's in fact using a center negative supply, because if we follow this pin, it goes through here and ends up on this rail, which is the ground rail. It's the common ground rail. And the positive part of the supply flows through here, through the power switch, and generates your 9-volt rail up here. There are capacitors and inductors over here which suppress any sort of voltage transients coming in here, especially if you plug in a live power supply while the power switch is on. That'll usually surge pretty good, but this will make sure that the surge is minimized and won't hurt the rest of the circuitry. So what about protection? Well, the first thing that I saw, or the first thing that I didn't see, was there's no fuse in here. There really should be a fuse in line right here, which would blow if there's too much current being supplied to the instrument. And but the reason for that would be that something in the instrument went wrong, shorted, and is drawing excessive amounts of current, and the fuse here would help prevent more damage than has already occurred in the instrument. But for some reason they left out this fuse, and so there is no overcurrent protection here. The specified power supply does deliver up to 800 milliamps, and if something in here is shorted and there's 800 milliamps flowing, further damage will occur. However, this diode over here seems to be the reverse polarity protection, and the way it works is it's pretty straightforward. If you have the proper power connected to this, your 9-volt rail will basically put 9 volts from here to here across this diode, and of course the following circuitry. That means that this diode under normal conditions is reverse biased and doesn't conduct. Ideally. In real life there'll be a small leakage current, but that we can neglect that for now and basically consider this this component to be electrically transparent to the rest of the circuitry when we have proper power coming in. Now, if the power input polarity is reversed, then we will see 9 volts from here to here, which means that the diode will be forward biased and essentially appear as a short circuit, and all current flowing in will find the path of least resistance, which will be through this short. And when that happens, there's no power delivered to the rest of the instrument, and hopefully there's no damage that can be done. The only downside is, of course, that now all of a sudden the power supply sees a dead short, and that's going to cause it to heat up and possibly start melting some parts in there. But you would assume that if somebody plugs in a power supply and turns on the instrument and it doesn't work, that they would unplug the supply. But as I said, it's an assumption, and that's just the way it works. This will protect the instrument, but it will put the actual power supply, even though it's the wrong one, in danger of damaging itself. So, to look at the analysis, my guess is, and I have seen this before, is that when the wrong polarity power supply is here, a lot of current flows through here and ends up damaging this. And if this is damaged, or specifically shorted, then it's basically there's a short or there's a short in here permanently, which means no matter what you hook up to it, power isn't going to get to the rest of the circuitry. And a circuit like this is also called a crowbar circuit, because pictorially you can imagine somebody taking a crowbar and laying it across the supply lines, which is essentially what this diode does when it is forward biased. But if it gets damaged and is permanent and turns from a diode into a jumper wire, then it permanently crowbars the supply, and you won't see anything working. So the next step is, of course, to have a look, to find this diode in on the circuit board near the power supply, and do some measurements on it. I went ahead and flipped the instrument over. One important part to watch out for is make sure you put some padding underneath it so that you don't damage the top panel by putting it on a hard surface. Now, in order to get out the back panel, or the bottom panel I should say, pretty much remove every screw you see that is holding the bottom panel in place. They are all around, and there's some also on this ledge over here. So get those out, which I've already done, and at which point the panel lifts off by lifting it up a little bit, sliding it forward to clear the keys, and you're inside. The next step is to remove the motherboard, which is over here and partially covered by a shield. It is held in place by 3 screws from the top, and also by a bunch of screws back here that hold the jacks in place, which are also mounted on that. Let's go ahead and remove those screws so we can see the motherboard. Here's the freed motherboard, flipped over. In order to get this out, after I removed all the aforementioned screws, there were some connectors. There's one over here that came out of that I just unplugged from here, and a flex connector, dual flex connector that goes to the front of this. When removing the flex connector, don't yank it out. There are locking bars on the connector on the board. They're gray plastic bars that you need to lift from the side with a screwdriver like this, and once you lift those locking bars, then the flex connector slides out easy. And when putting it back, make sure that the lock bars are released. Put the connector in and depress the slide connectors down, and everything will stay in place. Now let's have a look at our diode. Let's see if it'll focus on that. Doesn't want to focus, so let's pull back a little bit. Now remember, the board designator was D6, so we can see here that it says D6, and here's the diode. It is mounted upright because the holes are too close together for it to lay flat on the board, but that's done very commonly to save space. Now in this case, I already went in and I measured this diode using a meter in the diode setting, and in circuit the diode showed shorts in both directions. Not trusting that 100%, I went in, desoldered one of the legs of the diodes and lifted them out of the board and tested it again, and again the diode was shorted. So I took it out and replaced it with an equivalent, and so now you know what it looks like with the replaced diode. Let's go in and see how I figured out what diode to put in, because the original was not readily available to me. So if we look at this diode, this guy over here, of course, it is a 1SR35-100, and here's a partial data sheet of it. I checked the specs. I couldn't find an exact one like this readily from the sources I usually check, but since it's used as a rectifier diode with certain voltage and current ratings, I know that it can be substituted with a 1N4004, which actually exceeds the voltage ratings but is readily available and should do the job just fine. And that is exactly what I put in there. So this is a 1N4004 soldered in with the proper polarity, of course, because diodes are polarized, and the board clearly shows you where the negative terminal of the diode is supposed to go to. Everything is put back together. There are no screws left over, and time for the big test. And the power switch is in. It did come up. The display isn't super bright, but it did come up, so let's see if she squawks. keys work. The volume control worked, obviously. It's not scratchy. But I did spray some contact cleaner in there. And another thing I did that I forgot to film was there's a battery on the motherboard in a battery holder. I measured it and it was still showing almost 3 volts. And I also measured it at the RAM chip that it's powering, and that showed 2.8 volts. So there is more than enough power left in this guy to retain memory contents. And the battery, by the way, is very easy to exchange. You just follow the steps I showed you to open up the instrument and turn over the motherboard. And the battery was, I believe, on the lower right. And you just slide out the old battery and slide a new one in. And off you go. So for a demo, I'm going to let the instrument speak for itself. So what we'll do is go to the ROM play mode and let her rip. Well, thanks for watching, and I hope that you can use this information to fix similar problems in the keyboards you may have. Just remember, keep your power supplies labeled, preferably labeled with the instrument it belongs to, so you always know what to plug in. And I hope to see you again soon in the next episode. And the best way to be the first to see the next episode is to subscribe. And of course, a thumbs up would be much appreciated if you think the episode was worth it. Until next time.